Okay, this is number 4 on the last one, F. Now I'm going to do a couple things to speed it up and stay focused on the idea here. Before I even do the question, before I do the question, here's some things. And actually, this is not a bad idea in general, okay? This is what I would do if I was just thinking about the question to start with. Um, the g is the integral of f. So the first thing you want to realize is that means that the derivative of g is f, and the second derivative of g is the derivative of f. The next thing you want to do is you want to realize that each of these regions here, we're probably going to want to know what each of these regions is. Now, two of them are really obvious because they tell you. The region of A has a value of 3, and the region of B has a value of 5. Now that's the area, so keep in mind, depending on which way you're integrating, it's going to be plus or minus. Normally that's going to be a negative 3, and in this case that's going to be true. And this is going to be a positive 5, so keep in mind the area is 3, but the integral will be negative 3. Now the other two are a little different, and not that hard. The first one's pretty simple. It's a triangle. And this height is 3 and the distance is 4, so it's 1/2 base times height. So you can get that 6. So that's 6, that's 3, that's 5. The one that's a pain, the one that I kind of going to go quickly through that would take a lot more time if we were doing this by hand, is they give you, this is a parabola here. So you have to integrate from 1 to 4. To find this area, you're going to actually have to do an integral. Now, what I did to speed it up was, obviously take the antiderivative, and then you have to do f of 4 minus f of 1. I did f of 4. Now that's going to be a pain, right? You have to do 4 to the third, 4 squared, 4, and put it in. I worked that out pretty quickly. I cheated. I kind of did that ahead of time. And then I put the 1 in, and then you get negative 1/3, 5 halves, and negative 4. And that ends up being negative 11/6, but it's f of 4 minus f of 1, so it turns out that that's 9 halves or 4.5. So that has an area of 6, that has an area of 3, but it is negative, I get that, but remember, area is different than integral. This has an integral of negative 3, but an area of 3. Area of 5 and integral of 5, and that has 4.5 or 9 halves. Okay, now let's read the question. Okay, so again, we're making some observations before we start to hopefully make the question go smoothly. First question on the test. Find g of 0 and g of 4. So we want to put a 0 in here. So I want to do the integral from negative 4 to 0. And then I want to do the integral from negative 4 to 4. If I do the integral from negative 4 to 0, if I start going here from negative 4 to 0, that is 6 and that is 3. But remember, that area counts as a positive 6, and that counts as a... So you get that would have to have an integral of... Oh, what did I do wrong? 0 to... 4 to 0. Oh! No, what did I do wrong? Hold on. Negative 4 to 0. How do they get 9 halves? Oh, I'm an idiot. You guys, yeah. Hold on, I made a mistake here. This distance here is only 3, and the height is 3. So it's base times height, 1/2 base times height. This is 9 halves. Sorry about that. Not 6. Oh, that's a 4 here. So and there's a 1 here. So this distance is only 3. So that's 9 halves. So that's gonna be 3 halves. Sorry about that. Yeah, yes, that triangle there does not have a base of 4. It has a base of 3. It goes out to negative 4. So, and to negative 1. So the distance there is 3. And then, what if I go all the way out to 4? So then I'm going to have to do this one minus this one plus this one plus this one. So I'm going to do it now. I'm going to do that right now. 9 halves minus 3 plus 5, and again, this would be the hard part. That this actually will take more time. Minus 9 halves. Was the 9/2 cancel and you just get 2? That's surprising. That doesn't seem right to me. What did I do wrong? What did I do? Oh, because you're not subtracting the 9/2. We're adding the 9/2. Okay, so we have 9/2 plus 9/2, which is 9, plus 2 is 11. There we go. Yeah, there we go. So again, keep in mind that when you do integration from left to right, the 3 top ones count as positive, and that one bottom one, that area of A, is going to count as a negative. So there's the answer to A. The B question was to, hold on, I got to find the B question. Find the absolute min. Now remember, when we're doing absolute max and min, we have to check endpoints in. Now you have to check these in theory. Endpoints, -4 and 4 are the endpoints. And then we have to check, for minimums, we also have to check when it goes from negative to positive. So, it goes from positive to negative here, so that's a max. And there's the min. So you have to check 0 as well. So you have to check 0. Now, in theory, when I originally taught it, we'd also check the -1, okay? And so X and G. So now I think we're originally told, oh yeah, -4 is 0. So this one is 0. Obviously, if you integrate from -4 to 4, you get 0. And we did the 4. 4, we get 11. And then if you put the 0, I think we did the 0 as well. With 0, we get 3/2. And then, now the -1, you don't have to do. I always did it when I taught it, because when I taught absolute max and min before I taught relative max and min. Since we're looking for the min, and that's a relative max, it's certainly going to be less than the relative min. Okay, but if you want to just be on the safe side, 9/2. The way I originally taught the question was, okay, that has an integral of 0, 11, 3/2, and 5/2, and so the minimum is 0. The absolute min is G of -4 being 0. The min is 0. It occurs at -4. Then the last one, and the last one's not bad. When is the function? Okay, the graph is concave down on the interval -2, 12. Sorry, I'm reading the answer, not the question. Sorry. Find all intervals where it's concave down. Now, let me switch to green here. Let's do it verbally, and then let's do it visually. When is the function concave down? A function is concave down when the second derivative is negative. In this particular case, the second derivative of g is the first derivative of f. So when would g be concave down? When f is decreasing, right? So we need the second derivative to be negative, remember? So let's do the C question here. I want the second derivative to be negative, which means I want the first derivative to be negative of f, which would mean I want f to be decreasing. So just look where f is decreasing. Here, here, and here. So what was that? -1/2 to, -2 here. I think this is -2 to -1/2. And then there's another interval where it's decreasing here from 1/2 to 1. And then there's another one here. What is that? 3/2 to 4. Or is that 5/2? Let's look back in the direction here. It tells you in the directions where these points are. So it's not as tricky as you might think. It tells it, it's -1/2, 1/2, and 5/2. So this is -1/2, that's +1/2, and that's 5/2. That's where I got those numbers from. And that must be where G is concave. Sorry, concave down. Okay.